Hi, I'm Hitesh Sunita and I'm presenting my fine-tuned LLM model. The goal of this project was to take a pre-trained large language model and fine-tune it for specific tasks. I aim to significantly improve its performance on classifying movie review sentiments. So these are all the things which I have imported. I'll be using Hugging Face also. For this project, I chose Stanford Sentiment Tree Bank or SST2 dataset. It is a standard benchmark for sentiment analysis consisting of movie review sentences, as you can see here in the output cell. Okay. Uh, Key early step was to data preparation. I implemented basic cleaning to remove extra white spaces and filter out very short sentences crucially because uh, the original test set lacked labels evaluation. I repurposed the original validation set as my final test set and created new train and validation splits for original training data. Let's move on to split and training data. Yeah. I then tokenize the data using Distilbert base uncase tokenizer. I configured it to truncate pad all sentences to a maximum of 128 tokens, preparing them for the model input. Let's go to pre-trained model and justification. Yeah, yeah. For the core of this project, I chose Distilbert base uncase as previously mentioned. My justification is detailed here in the notebook. It is a lighter, faster version of BERT, ideal for fine-tuning on resource-constrained environment like Colab, while retaining high performance. It's perfectly suited for sequence classification like sentimental analysis. Let's move on to the next part. Yeah. Uh, to fine-tune even more efficient and prevent overfitting, I employed parameter efficient fine-tuning, specifically LoRa. As you can see, it significantly reduced the number of trainable parameters to just 1% the total of model parameters, making training much faster and more memory friendly. Yeah. Uh, The training environment was set up on GPU and I ensured reduced reproducibility by setting all necessary random seeds. Let's go to hyperparameter search strategy. Uh, for for hyperparameter optimization, I adopted a grid search strategy focusing on learning rate and number of training epochs. I tested three configuration: conservative, balanced, and aggressive, aiming to find the sweet spot for best validation score. Uh, let's go to the training loop. Yeah. So after fine tuning itself was managed by Hugging Face Trainer API, which simplifies the entire training loop, including logging and checkpoint due to time. I won't be able to run it now because it takes a lot of time, but I can show you the output here and how it went. It took a lot of time, like around 1.5 hours to do this. After training all configuration with a higher learning rate and fewer epochs, emerges the best performer based on validation with one score or over 9.0.92 in this model, and this was selected for final evaluation. Now let's go to result and performance analysis. To rigorously evaluate the best fine-tuned model, I implemented comprehensive set of memory, including accuracy, precision, recall, F1 score, and AUC, ROC on the independent test set. Fine-tuned model achieved an impressive score of, uh, as I showed, this was the score 0.88. Let's continue to the next section. To truly appreciate the impact of fine tuning, I compared our model against an untrained baseline Distilbert model, and my fine tune was performing like much better. As you can see, improvement rates are like almost double everywhere. Okay, let's move to comprehensive error analysis. Uh, Despite the strong performance, no model is perfect. I conducted a detailed error analysis. We found the model primarily struggles with nuances like subtle negative phrasing, mixed sentiments, and particularly sarcasm or irony, when the literal meaning doesn't match with the true statement. And we can see the result here of that cell. Let's move to pattern identification and errors. Uh, These insights allow me to identify specific error patterns and formulate concrete suggestions for a future work, such as targeted data augmentation of sarcasm and exploring advanced techniques for handling complex linguistic structures to further enhance model robustness. I'll scroll down to the next section. Finally, I have built a simple inference pipeline to demonstrate the fine-tuned model in action. Let's run a few. I have run a few example already, so I don't have to run it again. As you can see, the movie was absolutely fantastic. Uh, it correctly predicts positive with high confidence, and for the film was terribly and boring, it correctly it correctly predicts negative. Even for slightly trickier one, it was an okay movie, nothing special. It gives a reasonable prediction. It also implemented a batch prediction function for efficiency on multiple inputs. And I have generated some visuals here as well. Finally, this project successfully demonstrated the power of fine-tuning LLMs with uh, PEFT for specific tasks like sentiment analysis. I have achieved significant performance gains, understood key error modes, and built a functional inference pipeline. This approach is highly scalable and applicable to various domain-specific NLP challenges. Thank you for watching. Yeah, that's it from my side.